Introduction to Arduino IDE. Arduino software. The Arduino programming platform was designed in Java to help newcomers become familiar with programming. The language used to write programs in C or C++ and only uses two functions to make a functional program. And these two functions are void setup and void loop. The basic structure of Arduino programming language is fairly simple and runs in at least two parts. These are enclosed block of statements, that is, void setup and void loops, where setup is the preparation and loop is the execution. Both functions are required to work. The setup function should follow the declaration of any variable at the beginning of the program. That means, suppose you want to write int x equals to 0. In the first function to run in the program is run only once and is used to set pinMode or initialize serial communication. The loop function follows next and includes the code to be executed continuously, reading inputs, triggering outputs, etc. This function is the core of all Arduino programs and does the bulk of the work. Setup. The setup function is called once when your program starts. Use it to initialize the pin modes or begin serial. Like here, void setup, pinMode pin, output sets the pin as output. The loop. After calling the setup, the loop function is called. Precisely its name suggests, and loop consecutively allows to change, respond and correspond the Arduino board. Void loop. Digital write pin, high turns pin on. Delay. It pauses for 1 second. 1 second is delay of 1000. That means that for 2 seconds we would write 2000. Digital write pin low turns pin off. Delay 1000. Pauses again for 1 second. The programming syntax. Similar to other programming, the formatting requirements is the same. Double slash is the line is commented. This is for multi-line comment. This is used to define a block of code that starts and ends. This we do for all the loops. Semicolon is to specify the end of a line of program. The variables. A variable is a way of naming and storing a numerical value for later use by the program. A variable needs to be declared and optionally assigned to the value needing to be stored. The following program declares a variable called input. Int input variable is equal to 0. It declares a variable with the name input variable and assigns value 0 to it. There is one more example that you can read. The first line declares that it will contain an int, short form for integer value, and the second set of variable to the value at analog pin 2. This makes the value of pin 2 accessible elsewhere in the code. Variable scope. A variable can be declared at the beginning of the program before void setup, locally inside the functions, and sometimes within a statement block such as for loops. Where the variable is declared determines the variable scope. A global variable is the one which can be used in every function and statement in a program. That is written before the setup function. A local variable is one that is defined inside a function or as a part of the for loop. It is only visible and can only be used by that function itself. The following example shows how to declare a few different types of variable and demonstrates each variable's visibility. You can have a look and read it to understand more. Different types of variables with their data type. The byte. Byte stores 8-bit numerical value. Int These store the integer value. For storage of numbers without decimal points. Long, extended size data type for long integers, stored in a 32-bit value. The float. Float have numbers that have a decimal point and are stored in 32-bit value range. Constant. Arduino programming has a few predefined values which are called constants. True or false. These are boolean constants that define logic level. False is 0 while true is 1. High or low. These constants define pin levels as high or low and are used when reading or writing digital pins. High is defined as logic 1 and low is defined as logic 0. Input or output. Constant used with the pinMode function to define the mode of a digital pin as either input or output. PinMode 13, output. That means the pin number 13 of the Arduino is the output. Now conditional statements. If statement tests whether a certain condition has been reached, such as an analog value being over a certain number, and executes any statement inside the bracket. If the statement is true. If false, the program skips over the statement. For example, if you get more than 75% in your exam, then only your parents will give you a mobile phone. The format for if is, if some variable and the value, then do this thing. If condition in parenthesis is true, then the statement inside the brackets are executed. If not, then the program skips over and continues on after the bracket. If else. This is the decision-making statement. If you wanted to test a digital input and do one more thing if the input went high, or instead do anything if the input went low, you write this. If input pin is high, then do thing A, else do thing B. For example, if the room temperature is 40, then turn on the AC, else turn on the fan. For loop. The for loop is used to repeat a block of statement enclosed in a circular brackets a specified number of times. There are three parts of the for loop: the initialization, the condition, and the expression. Example: start the integer I at 0, test to see if I is still less than 20, and if true, increment I by 1 and execute the enclose statement. Declares int I is equal to 0, then you write the condition that I should be less than 20, and then the expression. Declare I, test if less than 20 and increments I by 1. The while loop. While loop will loop continuously and infinitely until the expression inside the parenthesis becomes false. Test if the variable is less than 200, executes enclose statements and increments variable by 1. The do-while loop. The do-while loop is same as the while loop, but in this loop the condition is tested at the end of the loop. So the do-while loop will also run at least once. The pin mode. The pin mode used in void setup to configure a specified pin to behave either as input or as output. Pin mode pin, output sets pin to output. Digital read pin reads the value from a specified digital pin with the result either high or low. Digital write pin, value outputs either logic level high or low. The pin can be specified as either a variable or constant. Digital write pin, high set pin to high. The following example reads a push button connected to a digital input and turns on an LED connected to a digital output when the button has been pressed. It would be better if you copy this program and paste it in your in the IDE of Arduino and run it. Like then, you will understand better. The LED is connected to the 13th pin. Connected push button to pin 7. Variable to store the read value. Void setup. Set pin 13 as the output and pin 7 as the input. Now, when you push the push button, then only the LED glows, since the push button is the input. Now void loop, value equals to digital red pin. Set value equals to the input pin. Set LED to the button's value. AnalogRead pin. Reads the value from a specified analog pin with a 10-bit resolution. This function only works on the analog pins 0 to 5. The resulting integers value range from 0 to 1023. Note: analog pins do not need to be declared as input nor output. AnalogWrite pin value. Write the value from a specified analog pin. This is the code that you can read to understand it better. Serial.begin rate. Open serial port and set the baud rate for serial data transmission. The typical baud rate for communicating with the computer is 9600, although other speeds are supported. Serial.println data for printing data to the serial port. Serial.println analog value sends the value of analog value. The following simple example takes a reading from analog pin 0 and sends this data to the computer every second. Programming math operators. This is the equal to sign known as assignment operator, percentage or modulo operator that gives the remainder. Addition, subtraction, multiplication and division must be familiar to you. Comparison operator. Equal to, we use double equal sign. Not equal to sign. For example, 12 is not equal to 10 is true and 12 is not equal to 12 is false. Less than and greater than operators. Adding two numbers. This is a simple code with which you can add two numbers. LED blinking sample program. Int LED equals to 13. Begin by using the variable integer and let's tell the Arduino which port the LED is in. Void setup, pinMode LED, output. Void loop, digital write LED high, delay 1000, digital write LED pin low. This program will result in a flashing LED. Compile. To compile your sketch, click the check mark. Make sure your Arduino is plugged into an available USB port. Click the arrow to upload if the program to Arduino. If everything is attached correctly, the LED should blink. Select board for transfer program. You go to Tools, you select the board, you choose Arduino Uno. And further in the port, you select to which COM port is the Arduino connected.